Networking and network security. A computer network is a group of two or more computers that are linked together. There are two main types of networks. A local area network connects computers within a school or home. All the computers on this network are within a very small geographic location. A wide area network connects computers across a broad geographic region, such as a telephone network. Both of these networks have the ability to have wired or wireless connections between workstations. The connection between each type of computer network requires its own protocols to determine how the computers will communicate with each other. There are two types of computer network protocols we'll review: Ethernet protocol and Wi-Fi protocol. Ethernet protocol is an efficient wired local area network. It has been refined to be able to send data at a rate of a gigabit per second, a seemingly instant speed. The image below shows how computers are linked through one common cable, called an Ethernet cable, which allows any computer connected to communicate with another. Ethernet cables are a specific type of cable used to connect workstations. They prevent data from colliding, so that it can be sent and received at any time by any workstation. It is backward compatible, meaning it can connect old and new technologies, as well as work hand in hand with Internet protocol. Wi-Fi protocol is now considered the most common type of LAN, also referred to as WLAN. It uses radio waves to connect computer workstations and devices, like smartphones, tablets, etc., instead of cables and wires. Interesting fact, Wi-Fi stands for wireless fidelity, meaning data stays true through a wireless transfer, where it must be distorted into radio waves. Then it is essentially recombined into its original form. Today, we see a combination of Ethernet and Wi-Fi connected LANs depending on the needs of the individual business, educational institution, or person setting it up. Some WANs connect smaller LANs, but also can have Ethernet and Wi-Fi components at various points of the connections. We will learn more about this in the next topic. The Internet is a vast digital space where data could get lost, damaged, corrupted, etc. So a client-server model was created that spans across many differently located networks. This model separates tasks and workloads between providers of a service, called servers, and those requesting a service, called clients. For example, Gmail stores messages on Google's servers and processes requests to send and retrieve messages. A host is a computer or device connected to a network on the Internet. For example, the hosts shown in this home network are a computer, a printer, and two smartphones. As a reminder, the Internet is a network of networks in which host computers and devices are connected. Hosts have unique IP addresses which are reachable by either an IP address or domain name, which will be discussed later. For example, NJCTL.org has an IP address of 35.162.99.125. The IP address system is comparable to a country's mail or postal system. Just as a house has its own street address, each computer or device has its own IP address. When data or mail needs to be sent to the computer or device, the Internet knows the location to send it. A host connects to the Internet through a router. A router is a dedicated computer that transmits data between networks within the Internet. You can think of the router as the central location of the LAN. We will learn more about routers in the next topic. The diagram below shows a broader picture of how routers provide hosts with access to the Internet. Here's the tricky part. A client is a piece of hardware or software that accesses a service on a server. It is easily mistaken that a client and a host are the same thing, but they're not. A host is a computer or device, whereas a client can be software on a host. In fact, a server is on a host computer by itself, where it provides the functional service needed by the client. Therefore, a host can take on both server and client roles. A server shares its resources with their clients. However, clients do not share any of their resources. Along with email, the client-server model is used by the World Wide Web. The resources on the World Wide Web can be accessed by browsers, such as Chrome, Internet Explorer, Safari, Firefox, etc. Web browsers are client software programs that allow users to access World Wide Web resources. The resources on the World Wide Web are hosted by web servers that respond to Hypertext Transfer Protocol, or HTTP requests by clients. Hypertext Markup Language, or HTML, is the standard language for data designed to be displayed in a web browser. Browsers, such as the ones mentioned, Chrome, Firefox, and Safari, need a markup language such as HTML to provide the backbone structure of how the content and resources located on a web page should look. Markup languages are designed to guide and format content that is viewed on the Internet. An Internet protocol, or IP address, is a numerical label assigned to every device connected to a computer network. The first major version of IP was actually Internet Protocol version 4, IPv4, which defines an IP address as a 32-bit number. This was used in the first production of the ARPANET in 1983. However, at this size, there's only room for a finite number of addresses, about 4.3 billion. As more addresses were needed, the IP address needed to be bigger in size. Therefore, a 32-bit number became a 128-bit number called Internet Protocol version 6, IPv6. It was created and has been deployed since the mid-2000s. IPv4 addresses use a 32-bit dotted decimal notation, which gives 2 to the 32nd possible addresses, equaling about 4 billion hosts. Below is an example. Notice there are 4 parts separated by decimals, each with the capability of holding up to an 8-bit number. Newer IPv6 addresses use 128 bits in hexadecimal notation. This allows for 2 to the 128th possible addresses, which is about 3.4 times 10 to the 38 hosts. Below is an example. Notice that there are 8 parts separated by colons, each with the capability of holding up to a 16-bit number. Trying to remember all those numbers in an IP address is a very ineffective and inefficient way of navigating the web. That's why the Domain Name System was created. Domain Name System, or DNS, is a naming system for services and resources connected to the Internet. It translates various names, called domain names, into IP addresses that designate the specific location of that resource on the Internet. Think of it as a phone book that connects names to numbers. The DNS allows users to find information without looking up or memorizing IP addresses. An Internet domain name is organized into a hierarchy. For example, each part of the domain name for Facebook has a specific meaning. HTTP:// is the communication protocol, www is the subdomain, Facebook is the second level domain, aka the domain name, and com is the top level domain. In these two pieces, facebook.com, are called the root domain. The diagrams on the next few slides show the hierarchy of each section in a domain name. The root domain is where all domain names are stored. Top-level domains are the second largest group of domain names. Second-level domains are the main part of the domain name recognized. It usually specifies the organization or business, like NJCTL or Wikipedia. Subdomains are domain groups smaller than second-level domains. The www is actually a smaller domain group under each second-level domain. Let's do an example to better explain. A fully qualified domain name, or FQDN, specifies its exact location in the hierarchy. So the FQDN, www.facebook.com, travels this path down the hierarchy. .com, Facebook, www. Domain names are vital because they are linked to specific IP addresses through the domain name system. The DNS has a network of servers that maintain routing tables that associate domain names with IP addresses, such as the one shown below. Practice questions.